Hi, this is going to be the second part of multiplying and dividing monomials, and that other video was really long. These problems get pretty intense. They get so intense that I actually didn't do one of the examples that I had to do also. I moved it to this video. So yeah, this stuff is a big deal. It's a really big deal. So it's just something that we take some time to learn. We're taking our time learning it. Hopefully this video will be far shorter. Let's get to it. First example I'm going to do. This is the example I skipped. So we've done a variable. What if we have two things dividing? What happens? What if they're multiplying? What happens? Well, now this is taking the other one of what if you have a power, a number, a monomial, the whole thing raised to a power. That's what this is. So we're going to expand this out. My first thing is, well, anything squared, if I have got something to the second power, I can write next to itself 2 times. I can write it, it's going to be multiplied together 2 times, the same number. So so we're just going to expand it out. This is negative 5 m n to the 5th times negative 5 m n to the 5th power. That's what that is. So we've done that. Now we got to think, well, what's inside of each one of them? We've got negative 5 and m are pretty easy, right? And this gets a little tricky. Do you need parentheses? Do you not need parentheses? I could go either way on that, and my eraser is a little tricky. I have to play to get the work. I would put negative 5 in parentheses. Everything else doesn't have to be, just because that makes it look better. 1, 2, 3, 4, 5 n's, right? And then I'm going to write the same exact thing again. Negative 5 in parentheses m, then 1, 2, 3, 4, 5 n's. I'm going to rearrange, get stuff next to each other. I'm going to have negative 5 times negative 5, m times m, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And here we are. Let's just do it. Negative times negative is a positive. 5 times 5 is 25. How many m's do I have? 1, 2 m's. M to the second power. How many n's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N to the 10th power. And you can see this example could get way worse if I changed, like if I made that 2 a 3, like raise this 2 right here to make it a 3. Now we got to do it 3 times? Ridiculous. Ridiculous. Just, Let's play with the properties a little bit and think about what's going on. This property is a little different because the other ones are like, yeah, I can see why that's true. This one's just like, okay, I understand why it's true because of the when I do expand it, it makes sense. But when I do that wouldn't make sense unless I did the expanded first. And that's kind of how I feel about it, so it's okay if you feel the same way. Here's how this one works. Color code never killed anybody. Well, maybe it did, and I just haven't heard about it yet. He died watching this video. I apologize. Here we go. This basically property is all in one step. I'm going to take each color and put them in their own parenthesis. And yeah, I am giving them a little bit of space in between. Every single buddy is going to get a second power. That's the second power, that's the second power, that's the second power. It's kind of like distributing. What's going inside of each one? Well, I'm glad you asked. Basically the colors, the red, negative 5 goes in there. M goes in here. The n to the 5th goes in here. So they all separated. And then they're all going to come back together. What's negative 5 squared? Negative 5 squared, well, 2's even, so it's got to be positive, so it's going to be 25. M squared, there's just an m in there. M times m, that's just going to be m squared. Nothing special about that. It's m squared. Just lose the parentheses. Oh boy, we got a power raised to a power. Well, that means it's n to the 5th times 2. Remember, we multiply the exponents together when it's power raised to a power. And that's just equal to 25 m squared n to the 10th power. Hey, look, same thing's over there. Two very different ways of doing it. I think the color coding is a beautiful way of going about it, just because that helps you really see what's going on. And don't just do it on your notes. Do it on, like, when you're working in class or at home. It's just good syntax. Makes it look good. Make it look nice. All right. That's the last example I was supposed to do on the other video that ended up being super long. Let's do 2 more examples and call it a night. And we're only doing them one way. We're just using the properties. Example number 2. I have negative 9r squared times s to the 7th times 2/3 r9th s. Properties. Oh man, let's use some properties. I'm going to rewrite it. But I'm going to rewrite it in Wonka vision. Color. Let's use the R's in green. Yay! Let's use the S's in blue. Yay! So remember, these are just multiplying. This is going back to the first 2 examples in the other video. I'm going to rearrange. I'm going to put my reds in one bubble. I'm going to put my greens in another bubble. And I'm going to let them figure out what's going on in their life. So we got negative 9 times 2/3 s to the 7th times s r squared times r to the 9th. And negative times a positive is definitely negative. What do you want to do first? Do you want to multiply or divide first? Let's multiply first. 9 times 2 is 18 divided by 3, right? R, we add those exponents together because they're multiplying. So 2 plus 9, right? And in the other parentheses, s to the 7 plus... Dude, what power is that s to? It's by itself. There's just one of them. Oh, right. It's just one of them. Remember, if there's no variable exponent, you just put a 1 on it, and that makes it that's the exponent. So it's 1 plus 7 equals negative 8 divided by 3 is negative 6. 2 plus 9 is r to the 11th power, and 7 plus 1 is s to the 8th power. And that's it. Look how nice and neat that is. Here's the us color coding. Here's the commutative property of multiplying. And then the associative property lets me multiply this together, and this together. That's 3 different properties right there. Moving stuff around, doing stuff in the order I want to do it in, and then the exponent properties. 3 properties. Bang, bang, bang. Right there. Number B. 12a to the 5th, b to the 4th, divided by 8a to the 4th, b to the 11th. Here we go. First off, that's right. I'm going to put a divide line first, and I'm going to put 12 and 8 in red. A to the 5th, a to the 4th, a, Canadian a, never mind. B to the 4th, B to the 11th. I think the B11 were bombers too. I don't know. I know I've been making you rewrite with the parentheses, but really you can do that right here. Just make sure no one's looking when you do it, but that's fine if you do that. You don't have to rewrite it with the parentheses. 12 and 8. What can I divide 12 and 8 by? 2. I can use 4. Go with the bigger number. Please divide top and bottom by 4. We're going to simplify. 12 divided by 4 is 3. 8 divided by 4 is 2. Okay? And actually, the book did this. They left the coefficient out there in the front and didn't make it one long fraction, so we'll do the same. 3 over 2 times a to the 5th plus 4. Don't plus 4. It's a to the 5th minus 4. Come on, guys. We're dividing, so we subtract the exponents. Times b to the 4 minus 11. See, 5 minus 4 is 1. I'm just going to put a. You don't need to put 1 right there. It's a. B to the negative 7. So now comes the fun part. What goes on top, what goes on bottom? 3 goes on top. A is positive, so he's going up there also. Divided by 2's in the denominator. B is a negative 7 on it, so it becomes positive 7. The exponent becomes positive 7 when it's moved to the denominator. That's example B. Yeah, it's a lot of stuff going on. A lot of properties, a lot of keeping track of different things. But if you stay organized, you color code, it really makes it a lot easier, especially the color coding. So bring some crayons and color pencils to class. It'll definitely help you. Okay, well, have a great day. See you next time.